Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video in Engineers in Progress. So, the solutions to these uniform motion problems are not so detailed, so that those who can follow it will have a greater chance in improving their thinking skills. Um, but for those who want to have detailed solution and you want illustrations, then you can, by pausing the video, you can anticipate the problems as long as the answers are the same. So this is part of the training that I'm intending to have for my viewers and subscribers. I don't want you to just follow the explanations because that's memorization. In my experience, you will really not develop if you keep on just following the solutions. I always set up the equation and for you to think. You can solve the problems presented here by pausing the video if you want. So you have to think for every equation that is set up here, and I want to solve the problem in a short way also. So this is still on uniform motion problems. The problems here are in general average. Challenging problems will be on the last part of the video. Future videos, I mean. So a freight train traveling at an average rate of 30 miles per hour leaves San Francisco for Los Angeles. 5 hours later, a passenger train traveling at an average rate of 55 miles per hour leaves San Francisco for Los Angeles. How far are the trains from San Francisco when the passenger train passes the freight train? So it means that the distance would be the same for this condition when the passenger train starts to overtake the freight train. They have the same path. So distance of the freight train is equal to distance of the passenger train. They only differ in their travel time. The travel time for the freight train is 5 hours more than that of the passenger train. So we will call the travel time of the passenger train as T and the travel time of the freight train as T plus 5. And they also differ in their average rate or speeds. So distance of the freight train equals distance of the passenger train. Distance of the freight train is the speed of the freight train, which is 30, and the travel time is t plus 5, while the distance for the passenger train is average speed 55 times time t. So 30 times or speed of the freight train time of travel time of the freight train equals speed of the passenger train times time of the passenger train. So this is a detailed solution actually. So substitute 30 times t plus 5 equals 55 times t. So 55t minus 30t is 25t on the right side, and in the left side 30 times 5, 150. So 150 equals 25t. Solving for t is 6 hours. So that's the travel time of the passenger train when it is about to overtake the freight train. Since the question is how far are the trains from San Francisco when the passenger train passes the freight train, so it is equal to the speed of the passenger train 55 times 6, because this is the travel time for the passenger train. But it is the same distance as that of the freight train because the freight train is about to be overtaken. So 55 times 6 is equal to 330 miles. Problem 29. On a trip, Jen noticed that her car averaged 21 miles per gallon of gas except for the days she used the air conditioning, and then it averaged only 17 miles per gallon. If she used 91 gallons of gas to drive 1,751 miles, on how many of those miles did she use the air conditioning? So this total distance is the distance uh, covered in two conditions. One, when the air conditioning is being used, the consumption is 17 miles per gallon times the number of gallons used when Jen used the air conditioning. I'll call that XA. So 17 times XA. Then plus the distance covered when Jen did not use the air conditioning, so 25 miles per gallon, and the number of gallons consumed would be 91, total consumption 91 minus XA. And distance equals distance when the car uses air conditioning or the air conditioning is used, then distance when the air conditioning is not used. And we will call this uh, rate, but rate in miles per gallon instead. So 17 miles per gallon times 1751 equals 17 miles per gallon times XA plus, so this is using the air conditioning, plus rate when the air conditioning is not used, V sub NA times 91 minus XA. So let's solve for XA first. And the distance uh, in miles when the car is when Jen uses the air conditioning of her car is this distance here. But let's solve for XA first. So 1751 is equal to 17 times XA, then plus 21 times quantity 91 minus XA. Simplifying, 1751 in the right side is 17XA minus 21XA, so that's negative 4XA. Then 21 times 91 is equal to, so negative 4XA plus 1911. Transpose negative 4XA to the left, and 1911 minus 1751 is equal to 160. Solving for XA is 40 gallons. Therefore, we can now compute the distance or the number of miles when Jen uses the or used the air conditioning, and that is 17 times 40, this distance here. So it is equal to 680 miles. So 680 miles is the number of miles used, number of miles covered by the car when the air conditioning was used. Problem 30. Jane drove 30 miles to work each day and pick up a friend on the way. If she was able to average 40 miles per hour on the trip and drove 15 minutes longer with the friend than without him, how far did she live from her friend's house? So remember that the average speed of Jane is 40 miles per hour, and if she pick up her friend, the travel time will extend by 15 minutes or 1/4 hour longer with a friend than without him. So meaning to say, because this is the extension travel time when Jane pick up her friend, then the distance of her friend's house from her is equal to the speed, average speed times that time. which is 1/4. So therefore, distance equals distance of the friend's house is from Jane's house is V times TF time when Jane pick up her friend. And that's the extended time, which is 15 minutes longer or 1/4 hour. So 40 times 1/4 is equal to 10 miles. So that's it. Problem 31. Charles and Paul enter the Center Point Comfort Hill Country Run. Charles runs at 8 miles an hour and Paul at 6 miles an hour. If they start together, how long before Charles is 1/4 miles ahead of Paul? So distance of Charles is distance of Paul plus 1/4. So d sub p plus 1/4. Distance equals rate times time, speed times time. So for Charles, it is 8 times t because they start together and so it means at the same time also. So it is 8 times t, then distance traveled by Paul is equal to speed of Paul 6 miles an hour times t also. So 80 equals 60 plus 1/4. 80 minus 60 is 2t equals 1/4. So t is 1/4 over 2 or 1/8 hour. So times 60, so that we express the answer to minutes, that would be 7.5 minutes. 32. Joe can run a certain course in 9 minutes and Al can run it in 6 minutes. If they start at opposite ends and run towards one another, how long will they run before they meet? So let us denote the distance between them initially as d. So therefore, if the distance, the constant distance between them is d, then since Joe can run that certain course in 9 minutes, the rate of Joe is that distance. It may be in meters per minute. So d over 9. D over 9 is the rate of Joe and or speed of Joe. Then d over 6 would be the speed of uh, Al or the rate of Al. So therefore, this rate times time is distance. So distance traveled by Joe plus distance traveled by Al is equal to distance because the distance is the same until they meet. So d over 9 times t because they start at the same time. So d over 9 times t plus d over 6 times t equals d. So we can cancel d common to both sides of the equation. Then this reduces to t over 9 plus t over 6 equals 1. So multiply by the LCD. The LCD is 18. So 18 times t over 9 is 2t. 18 times t over 6 is 3t equals 1 times 18 is 18. So 2t plus 3t equals 18. Therefore, t is 18 over 5 and that is 3.6 minutes. Problem 33. Don rode his motorbike 20 minutes to Helen's home, and then the two drove in a car 30 minutes to a beach 35 miles from Dawn's home. If the car's speed was 10 miles per hour faster than that of the motorbike, how fast did the car travel? So the total distance traveled is 35 miles, and it consists of the distance covered for Dawn to ride his motorbike in 20 minutes, then plus another 30 minutes ride from Helen's house to the beach. So distance equals speed of the motorbike times travel time of the motorbike plus the speed when the two rode the car times the travel time for the car. So since the speed of if the car speed was 10 miles per hour faster than that of the motorbike, then the motorbike speed would be speed of the car, which is denoted here by V sub c minus 10. So d 35 equals quantity V sub c minus 10. Let's just make V sub c as the unknown. So V sub c minus 10 times time, which is 1/3 hour. 20 minutes is 1/3 hour. 20 divided by 60. Then plus V sub c times 30 minutes is 1/2 hour. 30 over 60 is 1/2. Simplifying, 35 equals V sub c times 1/3 plus V sub c times 1/2. That is 5/6 V sub c. So 35 plus 10/3 equals 5/6 V sub c, where 10/3 is negative 10 times 1/3 transposed to the left. So that's why it's 10/3. Then take note that 1/3 plus 1/2 of V sub c is 5/6 V sub c. So just simplify that using algebra. Or for those who are allowed to use the calculator, you can easily verify that. Multiply everything by, or simplify this. 3 times 35 is 105 plus 10, 115 over 3. 115 over 3 is 5/6 of V sub c. So the LCD is 6. Multiply everything by 6. So this becomes 6. 115 over 3 is 2 times 115. 230 equals 5 V sub c. So finally, V sub c is 230 over 5. So the rate V sub c is equal to 46 miles per hour. So that's the rate or the speed of the car. Problem 34. A bicycle club left the campus to ride to a park 24 miles away for an outing. Lynn left from the same place by car with picnic supplies 1.5 hours later, traveled at speed 4 times as fast, and arrived at the park at the same time as the cyclist. How fast did Lynn drive? So the rate of Lynn is 4 times the rate of the cyclist. And the distance is the same because Lynn arrived at the park at the same time as the cyclist. So distance is distance that Lynn traveled plus equals distance that the cyclist traveled also. And distance that Lynn traveled is 4 rate of Lynn, which is 4 times the rate of the cyclist, times travel time, which is equal to t, then equals the distance traveled by the cyclist is rate of the cyclist v sub c. Travel time of the cyclist is 1.5 more than that of Lynn's travel time, which is t. So t plus 1.5 or 1.5 plus t, travel time for the cyclist. So 4 times v sub c times t equals v sub c times quantity t plus 1.5 or 1.5 plus t. We can cancel v sub c, so we have 4t equals 1.5 plus t. So 4t minus t is 3t. 3t equals 1.5. So t is 1.5 over 3, and that is 1/2 hour. So having found t, which is 1/2 hour, then the question is, how fast did Lynn drive? That is 4 times v sub c. And since 4 times v sub c times time is equal to distance, which is 24 miles, so 24 miles equals speed of Lynn. I'll just call it v sub l, although it is 4 times v sub c. It's not required here. We'll just call it v sub l. Then since travel time of Lynn is 1/2 hour, so times 1/2. Therefore, we can now compute the rate of Lynn, the speed of Lynn, which is 24 times 2, and that is 48 miles per hour. 35. A jumbo jet left an airport at the same time as a small private plane that followed the same flight same flight plan during the first hour of its flight. The speed of the jet was 5 times that of the small one, and at the end of the hour, it was 500 miles ahead. What was the speed of the large plane or the jet? So we'll call it V sub j. Now, take note that they start at the same time. So the jumbo jet is flying faster because the rate is 5 times of the small one. So if this is the starting point, the jet will be here after at the end of 1 hour, while the small private plane would be left here. The distance traveled by the small private plane is v sub plane times t times 1, while the distance traveled by the jumbo jet is speed 5 times uh, speed of the small plane, private plane times 1 hour. And the difference of the distance traveled is equated to 500 miles. So distance equals speed of the jumbo jet times travel time of the jumbo jet minus speed of the small plane times travel time of the small plane, which is in this case 1 hour for both. So 500 is equal to speed of the jet because it is the speed of the jet which is required. So we'll just call it v sub j, then travel time 1 hour, then minus the speed of the plane is 1/5 of the speed of the jet because the speed of the jet is 5 times of the plane, small private plane. So in terms of the speed of the jet, the speed of the small plane is 1/5 of v sub j or v sub j over 5, and the travel time is also 1 hour. So 500 equals Vj minus 1/5 of Vj, that's 4/5 of Vj. Therefore, we can solve for the speed of the jet, which is 5 times 500 over 4, and that is equal to 625 miles per hour. Lastly, for this video, Walt and Gail left a stable for a ride to a mountain lookout. On the way up, they averaged 3 miles an hour. On the way back along the same trail, they averaged 5 and 1/4 miles an hour. And the return trip took 5 and 7 hours less time than the outward trip. So how long was the entire horseback ride? So the distance is the same, outward and going back, return. But the total length of the horseback ride is double that distance outward and going back because the trail is the same. So that's the idea. So after we compute for time in going outward, then we compute the distance 3 times time in going outward, then multiply it by 2, or we double that times 2 because the question is how long was the entire horseback ride. So distance equals d sub u equals distance of the return trip. So this is the distance, and we'll double this after we solve for the travel time in going outward or going uphill. So distance going uphill is average speed 3 times time going uphill, which is t sub up, then equals in going back of the return trip. So we have 5 and 1/4. That's 5 and 1/4. Speed is 20 plus 121 over 4, and the travel time is t sub u minus 5 over 7 as mentioned here. So 21 over 4 times t sub u minus 5 over 7. So simplifying, 3t sub u equals 21t sub u over 4 minus 15 over 4. 21 over 4 times negative 5 over 7 is 15 over 4. So 3t sub u equals 21 over 4t sub u minus 15 over 4. Transpose 15 over 4 to the left, so it becomes positive 15 over 4. Then 21 over 4 minus 3 is 21 minus 3 times 4, 12. So 9 over 4 t sub u. So 9 over 4 t sub u in the right side. So 15 over 4 equals 9 over 4 t sub u. Cancel out 4 because these are both denominator. So t sub u is 15 over 9, and that is 5 thirds hour. So meaning to say it will take 5 thirds hour for the outward trip, and the distance is this one. Then the total length of the horseback ride is times 2 of this distance. So total distance is 2 times 3 times tu. So 2 times quantity, 3 times 5 thirds. So cancel 3. So 2 times 5 is 10 miles. So that total length of the horseback ride is 10 miles. So that's it for this video. I hope that you gain another important concept in problem solving.